As data centers continue to climb up the list of priorities among Canada's major projects, this shift brings transformation, not only to our electrical infrastructure at large, but also to those across the country who work hard to build and maintain that infrastructure. From new skills to new solutions, the growth of data centers is driving emerging demands in how Canada's electrical contractors and engineers think about and successfully manage power systems. As part of Electrical Business's Data Center Theme Week, brought to you by Champion Fiberglass, I'm very excited to be joined by Matt Fredericks, VP of Sales and Marketing for Champion Fiberglass, here to help dive into the unique demands brought on by this current emphasis on data centers, and along with sharing some of the lessons that he's learned for keeping up with these changes. Welcome, Matt. How are you doing today?
Not too bad, Jack. How are you?
I am well. I am well. So just to start off this conversation from a big picture perspective, um, I just kind of want to know from an electrical infrastructure standpoint, what would you say makes data centers fundamentally different from other large commercial or industrial projects?
Yeah, that's a really good question. There's issues with complex installations and complex cabling, and that comes all the way from the substation, to the fence with very, very, very large duct banks that are dealing with high ampacity, high voltage, and needs to dissipate heat. Then you're going past the fence into the data center. That might require conduit, it might require cable tray, customized building entrances, cable bus. And then you get into the data center and you're dealing with more tray, more conduit, specialized floors that have conduit below it, racking above, different strut requirements. You're dealing with a space that had somebody ask me this recently. It was my fiance. She was asking about job creation of all of these data centers, and they are in remote places because of power demand. Like, oh, this must be really good once data center is built. Well, you've got a low populace of people that are really ever going to enter into these data centers. So you have to pick the right equipment installed appropriately that's going to last a long time. So ideally, these data centers work and we don't have to go into them, if you know what I mean, besides cleaning and maintaining things of that nature. So, complexity with climate and cooling. You see a lot more data centers popping up, obviously, in Canada. If you can tell by my regional diction, I don't have a Texas twang. I'm from Canada South. I live in Minnesota, and we have a lot of data centers popping up in the Dakotas now because of the natural ability to cool as well. So, I mean, data centers are complex because you're not building them for human occupation, but you're building them to last, a lifetime, similar to the way that you build infrastructure, but it's technically more or less replacing office buildings or filing buildings, if you will. So it's kind of interesting to think about because it's just totally off the wall compared to what we're normally used to dealing with, not only in the electrical industry, but in the construction industry in general.
Absolutely. And so when it comes to all of these complexities, um, specifically for electrical teams, I'm wondering what would you say are some of the conduit-related challenges that that electrical worker or electrical workforce could most often encounter when building or expanding, this version of the modern data center?
Yeah, I mean, right off the bat, I would say labor. Are you picking a conduit that's really easy to put underground, that's not super labor intensive? We're seeing a lot more mechanical and civil contractors installing the conduit outside of the fence, these large scale duct banks. So they want conduit systems that require less skill to put together, that are easier, faster, safer to put together. Then soil conditions come into it. Certain soil, if you're in the Midwest like me, if you're down in Iowa, they've got feet of nice blacktop soil. That's why you see a pile of data centers in Cedar Rapids, Des Moines, areas like that, because There are very areas where there might be more caustic soil. You're going to want to deal with a conduit that has better corrosion resistant properties, or like in Nevada or Arizona. Maybe you're dealing with rock. You can't really use a borable conduit. And then, of course, depending upon the soil type, the ampacity, the voltage, how the duct bank is set up, if it's going to be direct buried concrete encased using red dye concrete or regular slurry, you've got to do all your heat calcs, make sure that your cable, your conduit, and what your conduit is sitting in agrees with it. And that's literally just the underground part of deciding what you want to do for duct banks. So then you think about extrapolating that out with like, how do we make sure, building entrances are perfect? Like, what type of mechanical seals are you using? Are you going to use exposed cable tray with MC or clad cable, metal clad cable, or are you going to use cable bus? It's enclosed. There's piles of different considerations that one might have to use, but honestly, I would say it starts with labor. We are consistently hearing from all of our contractors that labor right now is everything. It's really, really hard to get enough people to complete the work. That's the holdup.
Yeah, no, and it's definitely a widespread problem, I would say, in all of the trades, but especially I think when it comes to infrastructure or electrical infrastructure, when there
Mhm.
are these project demands and this big push, it really just highlights the need for labor and the gaps that that lack of labor really exposes. Um,
Yeah.
but then going on to all of these other complexities that you kind of touched on in your last answer, um, such as conduit material selection. So I'm just
Mhm.
wondering, how does that selection process, or what, companies or contractors end up selecting, how does that impact the reliability and maintenance in these sorts of environments where continuous operation and limited downtime windows are some of the characterizing features?
Mhm. Yeah, I mean, akin to like an infomercial where you hear people say like set it and forget it. That's how people want to deal with underground duct banks or really data centers just in general. We know that these data centers are supposed to be there, stand the test of time, and we don't want any interference happening. So what does that mean when it comes to conduit selection? Well, we want to make sure whatever we're putting in the ground, in the air, in the building is going to last as long as humanly possible. We want to make sure that we're not running cables at their peak ampacity if that peak ampacity is at the ceiling of what the conduit can handle. Or you can pick a conduit type that can handle greater ampacity in case you need to turn up the ampacity to the data center and make that data center more productive. So, I mean, mechanical protection comes into it too. Obviously, you hope that nobody's going to be digging anything up in the area around the data center. There's fencing and whatnot, but you also have all of that power coming from a substation, normally from outside of the fencing. That what if a road crew hits it? What if, farm implement or who knows, ground shifting, ground shear, earthquakes, blah, blah, blah. So you want to have something that's robust enough to handle any of the elements that are below ground, that allows for good heat dissipation, that's easy to pull cable through, that's fault resistant. So if you have a fault, God forbid, inside that duct bank anywhere, you can simply reconductor it, rather than having to put in a ton of blanks or literally just having a dead cable that's melted or welded itself to the inside of the conduit. So it's kind of this Goldilocks thing, really robust hardened infrastructure, or rather conduit that's gentle on the cable and safe to install, easy to install, lightweight for the manufacturer. That's why I work for Champion, because I see sort of this dichotomy of PVC versus steel. And this fiberglass is sort of a happy middle choice between the two. Lightweight, robust, easy to pull cable through, fault resistant, on and on.
So then obviously like another factor, as opposed to, the durability and the efficiency and its lightweight nature and stuff is, safety is a huge thing when it comes to any sort of electrical work, but especially data centers where, they're increasingly dense with power and fiber. So what would you say are some of the design or installation considerations that can help reduce risks during activities such as, cable pulls or just future upgrades?
Yeah. Well, certainly, from a safety perspective, having less tension in a pull means less tension on the pulling medium. Let's say if you're using a non-braided rope, like a simple pulling rope, there's going to be less chance of that snapping or breaking. But it's also, we'll expand on the term of safety or safer for the cable. It's safer for the cable jacketing as well, which is going to reduce fault resistance. Same with the material types as well. You look at inside the data center or outside the data center using non-metallic, um, which therefore are non-conductive materials. God forbid there's any stray current. You're not energizing up a conduit or strut or what have you. Those mediums are not going to be energized ever because they're non-conductive. And then, of course, from a labor standpoint, having something that's lightweight is really, really critical for the workers. You can go with products that are a tenth of the weight of steel or even a third of the weight of steel versus steel that requires a lot of different equipment to install safety precautions, and really keeping our tradespeople out of the trench is quite critical. Less time in the trenches, less liability for injury and God forbid death to happen.
No, that's great. So obviously, both you and Champion Fiberglass have a lot of experience in this space. And so I'm just a little curious as to what are some of the lessons that you and Champion have seen repeated across successful data center projects, especially when it comes to underground and concrete encased conduit systems?
Yeah, that's a really good question. I would say off the top of mind, one particular project comes to mind immediately, where we were able to work with a data center in the Midwest. It was right when we refer to it as the PVC crisis in the electrical industry. Canada dealt with it as well. It was when COVID was really in the thick of it. Resin was wonky. There were couple fires at plants. Just a lot of stuff was happening, and that contractor had a data center that was specified PVC. They ended up value engineering it to fiberglass. And what they ended up finding out was that they could install our fiberglass conduit 5 times faster in a duct bank over PVC. So they've consistently used the product since then, even though that there's pricing differential between the two now. There's another one that it's actually on our website. There's a case study published. You can take a look at it. It's I believe it's called Data Center Alley in DC. Something about I think it's like productivity increases in Data Center Alley. But needless to say, that one you can see that similar situation went from 4-inch PVC to 4-inch fiberglass, and they saved 63% on labor by using our conduit. So, lessons to be learned by switching your conduit medium. You can save time and money, specifically through labor. We also see time and time again the opportunity for um, contractors inside the fence to inform contractors outside the fence of, the opportunities that fiberglass has, not just putting those risers up into the data center, but actually bringing the power from the substation to the data center itself. And of course, now we have utilities that are using our conduit in generation facilities, transmission, distribution. So we're really seeing the power come from the inception all the way to the end user utilizing our system due to so many different features and benefits that we have. So, yeah, it's pretty cool actually.
Yeah, amazing. Thank you, Matt. So obviously, if this push is any indication, data centers are here to stay. And I also feel like with this emphasis on them, they're here to grow and expand as well. So as power demands increase and, medium voltage systems become more common in data centers, how would you say that those trends are influencing conduit system design?
Yeah, I mean, the demand for any products when it comes to data centers right now is extremely high. What we're seeing a lot of companies do, whether it be data center owners, contractors, distributors, is do much more pre-planning because again, that labor savings and the ease of pulling cable, all of these features and benefits that they can extend to the end user by using fiberglass conduit are really attractive. But planning is the most important thing. People are a lot more planful now, especially after COVID. I think post-COVID has changed a lot of behaviors in the construction industry in general because the supply chain went crazy. People couldn't get stuff. Um, Work from home has been pretty sticky. And even in the United States, if you look at construction trends in general, if you took out data centers in the United States metrics for office building construction, it would be down significantly. But it's been largely flat or slightly down or slightly up for a long time. And that's because our metrics down here, don't ask me why, include data centers as office buildings. So, between what folks are building for power generation, transmission, distribution, substation, and data centers, everybody's all, you know, starting to work in conjunction with each other. I think there's a huge push by a lot of these utilities to do more strategic undergrounding, which is helping the reliability of the power delivery to the data centers as well. So it just more forethought about being strategic and making sure that the system longevity, whether it's intra-building, outside the building with the utility, is hardened, really. In the utility space, we call it grid hardening. I'd say it's more so system hardening on the commercial and industrial space, and it's happening in the infrastructure space as well.
Totally. You mentioned how sort of everyone's beginning to work in conjunction with one another. And I'd
Yeah.
like to look at what that collaboration sort of looks like. So for any manufacturers out there listening, I'm just wondering in your opinion, how early should conduit manufacturers say be involved in data center projects and where along the line does that collaboration typically bring the most value for engineers and contractors and just the workforce on these projects?
Yeah, the initial design is where it is best. And why I say that is the contractor then receives the design to do their takeoff, their planning. As soon as they see that the materials are appropriately specified and they're not having to VE these jobs for heat calcs or labor or for whatever reason choosing to VE it, it's so much easier when the engineers are taking that initial step to think outside the box and say, you know what, I'm not just going to use my standard spec. I'm either going to write this product in as an or equal, or I'm going to change my spec to include it as an option on the front end. The earlier that thought gets into the stream, the better it is for the contractor, the distributor, EPC, whomever is handling all of it, that they can plan and make moves accordingly.
Totally. And so going back to that expansion that I was talking about earlier and any sort of future plans as this sector builds out, on the conduit system management side, how should these systems be managed to accommodate for any future cable expansions or just technology changes?
Yeah. I mean, traditionally it's been to run blanks to have enough space to accommodate future expansion. There's different engineering firms, contractors have a rule of thumb for the amount of blanks that they might run in a duct bank. But again, I would also say pick a conduit system that's going to allow for future expansion as well. And what I mean by that is the ability to dissipate heat faster, or if you need to reconductor with a new type of cable, make sure that you're using a conduit system that has a low coefficient of friction. That way, when you have to rack out that cable, it's easier to do so rather than a conduit system that has a high degree of friction. That even comes down to, let's say, the type of cable lubricant that you're using. Don't use a wax-based lubricant because that generally glues the cable to the inside of the conduit. You have to use semis to rip it out, which can damage the conduit system, or even products that are made to loosen that wax that ends up drying and essentially gluing the cable to the inside of the conduit as well. So it's from the macro level down to the micro level. Like the tiniest decisions can really impact your ability to expand the system as a whole. And I would also say, too, the data center companies are getting a lot smarter. They are building data centers in places that have a ton of water, a ton of space, and a ton of power now. You're not seeing tons of data centers be built, in the middle of LA. Geez, I wonder why. Power is expensive, land's expensive, on and on and on. You're seeing them be built in Canada now. There's great hydroelectric power. There's obviously a pile of space, and it's quite cold in Canada, which makes it more efficient to keep these data centers cool. So it's interesting to see sort of these, I would say, like more obvious points come to life now, when there's less resistance to building a data center in the middle of North Dakota, or, middle of a farm field somewhere in Manitoba or whatnot.
Amazing. So you kind of touched on some of the current trends informing everything, but as we reach the end of this conversation, I always like to kind of just take a look at what's coming up, what the next chapter might be. So, looking ahead, what would you say are some of the trends in data center construction that electrical professionals should not only be aware of, but be preparing for from an infrastructure standpoint?
Yeah. Yeah, I would say be prepared that a lot of conduit is being installed by multiple different disciplines now. You've got data centers that are being built at an extremely rapid scale where, you might have plans for 1 through 3, but the contractor says, yep, we know that there's 15 more buildings coming behind it. Um, Space and having enough space is really important. I can't say where, but I was in a area that had some, um, we'll say hills or small mountains in it, and it was critical to keep the data centers close to each other, and it was more cost effective to blow up some hills or mountains and build the data centers, basically on top of the rubble or rock rather than moving them elsewhere. So make sure you have enough space. You might have a contract for building one, but if you're a part of the um, planning for acquiring land, like, yeah, you want to make sure that it's, you know, in a space where you can expand handily. Um, Talk to your core suppliers ahead of time. Your conduit and cable manufacturers are heavily pressured right now by data centers and utilities alike. Create that relationship ahead of time as a contractor. See how you can work together. Maybe you can get master orders in, or advanced purchase agreements, making sure that you have a continuous stream of material. Don't rely on the supply chain to keep up, where you think, well, hey, we buy a lot of stuff. I can call and something will come in a week's time. There's so much demand for material right now. Cables got long lead times. There's shortages on other conduit types. Fiber optic cables have long lead times. I mean, you keep going on and on and on, and it's tough. So again, that pre-planning is critical, but also talk to the material manufacturers and see, is there a new technology coming up that will be available by the time we build this? Maybe they have a new conduit type or cable type or joining type that's available that will save, 10 to 15% on labor or allow the data center to run 20% more efficiently. Because a lot of these data centers, they're planning them like years in advance. And R&D, is constantly working at a lot of these companies. The electrical industry, for a lot of time, I feel like, people were like, oh, it's antiquated. It's still, cable and conduit and a light switch and whatnot. But there's a pile of development that has happened. It may look similar or seem simple, but you would not believe the engineering that's involved in, a switch or a piece of conduit or cable or something. So, make friends with the manufacturers, and we will try and help you.
Well, speaking of making friends and trying to help, Matt, as before we kind of end things for today, if anyone out there listening wants to get in touch with you or Champion Fiberglass to learn more about this stuff, where can they go?
Yeah, so our website is championfiberglass.com. You can contact me. It's mfredericks at championfiberglass.com. My contact information, as well as my entire team's contact information, is on the website. We've got local manufacturers, reps all across Canada that are more than able to help you. There's a map on our website where you can see who your local manufacturers rep. They're obviously a great local resource. We work with several electrical wholesalers, distributors in Canada as well that can help ferret out those requests. But if you have any comments or questions, please reach out to us or me directly at any time. And I'm more than happy to help you with whatever you may be wanting to know or want assistance with.
Amazing. Well, thank you so much, Matt, for joining us today and sharing all that insight. I hope everyone who tuned in had a great time. And before we go, I just want to give a big shout out once again to the sponsor of our data center theme week, Champion Fiberglass. Thank you to everyone for tuning in and have a great day.
Thank you.